Hello there, this is Tyler here for week 13, I believe, of Oceanography, where we are going over different extremes as far as temperatures, salinities, and pHs for our video for this week. So let's start with how pH is going to be not distributed. That's not quite the best word for it. I think it's just what pHs are where, kind of. So it varies pretty crazily. So it can vary from your depth, because it'll start very, very concentrated on the top, and then it'll dilute down sharply, and then it'll kind of spike, and then it'll go back down. And then the regions, there's definitely some warmer regions that have a higher pH, just because of their temperature, and then there's going to be some colder places that have low pHs. And as you'll see later on, the pHs are going to be a lot related to temperature. I have a couple graphs later on that I'll show you. And then weather can also play roles into it. And here's those graphs about the temperature. And then you can see here, this is the temperature of the surface of the ocean, or the sea surfaces right here. You can see that there's a stripe of warmer air in the middle, warmer sea surface in the area in the middle. And then you can see over here, it's on the more acidic side, is going to be the darker areas, the darker red. You can see there's kind of a belt of it that follows these patterns up here. And you can see that the temperature and pH are actually really closely related. And then depth here, you can see this is the pH, and it starts right up here at about 8 and 8.1, and it goes all the way down to 7.6 at around, I'd say, 700 meters, and then it just kind of goes back up into 7.8. The bottom end is kind of different than the temperature. You can see the temperature follows the same trend up until about here, and then it's kind of varies down. And then what kind of organisms can live in extreme pHs? I didn't really explain any extreme case scenarios, but in a lot of volcanic areas, there's going to be some high temperatures, high pHs, that some of these extremophiles, called sulfolobuses, can be there. And it's just a bacteria that is an acidophile, which means it can live in a acidic environment. I think it was up to around 100 degrees, or 70 degrees Celsius, with a pH of 3. So these guys can handle pretty much anything thrown at them. And they can be autotrophs or heterotrophs. So when they're in oxygen, an oxygenated area, they can cellular respirate and get their own energy from that. And when they're not, they can oxidize sulfur with their own oxidizing agents to create their own energy. And they're planktons, because with how small they are, they're bacteria, they get easily thrown around by the water. And yeah. And they're mostly found in volcanic areas, shallow hot springs, and they're definitely a lot more on the benthic side, because even though they float around a lot, they're almost always in some sort of hot spring right next to the ocean. And then the question I have for you guys is, where do you expect the most difficult living conditions to be in general? Like, for example, before I started this project, I was going to expect the more cold climates to be an extreme area. And really, if you look at it, you can find extreme cases all over the place. And just go into depth about that. That's going to be all for this week, guys. See you next week.